Look at this photograph. That towering structure perched on this caterpillar's head is actually a stack of its own old skulls. To grow, a caterpillar has to repeatedly shed its hard exoskeleton. But instead of discarding the empty head casing, the Gumleaf Skeletoniser keeps it. Up to 13 times it molts, grows a new, larger head, and pushes its old face shell upward, stacking them like nesting dolls. This bizarre headdress serves a highly practical purpose. When a predator, like a spider or a stink bug, moves in for a meal, the caterpillar swings its heavy stack of empty heads like a club to swat them away, or offers it up as a hollow decoy. If an enemy gets past the club, they face a second line of defense. Its body is protected by a dense coating of sharp spines. These hairs contain a potent toxin that causes severe skin irritation and blistering in larger animals that try to touch or eat them. Between a weaponized tower of false heads and a coat of toxic barbs, this insect has evolved an overlapping physical defense system that leaves standard predators with no clear point of entry. With its predators kept at bay, the caterpillar is free to gorge itself on its preferred food source, the vast eucalyptus canopies native to Australia. In this technical reference, you can see exactly how it feeds. The insect strips away the soft green cellular tissue while entirely avoiding the oil glands and structural veins. It leaves behind a frail skeletal outline, earning its name, the Gumleaf Skeletoniser. In its native Australia, occasional outbreaks are a known hazard, but when the Skeletoniser accidentally hitched a ride to New Zealand in 2001, it found a landscape full of eucalyptus trees and absolutely none of its natural enemies. Without predators, the population exploded rapidly across the Auckland region. This technical forestry record shows the severity of that unchecked feeding. Entire swaths of forest are completely defoliated. The damaged foliage takes on a bronze, dead appearance, making the trees look as though they have been scorched by a massive wildfire. When this physical armor works as intended, the Skeletoniser is left to strip entire forests bare, transforming a biological curiosity into an ecological disaster. Managing an outbreak across thousands of hectares of forest presents a unique challenge. You cannot simply crop dust entire regional ecosystems with broad-spectrum chemical pesticides without killing beneficial insects and polluting local water supplies. Physical removal isn't an option either. The sheer scale of the infestations, combined with those highly toxic spines, makes manual clearing dangerous for forestry workers. New Zealand researchers initially hoped local insect predators would adapt to eat the invaders. But native parasitoid wasps either failed to recognize the heavily armored skeletonizers as food, or simply chose easier, less dangerous targets. The solution had to be found back where the problem originated. Scientists initiated a classical biological control program, traveling to the skeletonizer's native Australian habitat to identify a specialized natural enemy that had already evolved to bypass its defenses. Defeating an impenetrable physical threat required researchers to look past the armor and find a biological exploit. The organism researchers eventually identified was Cotesia urabae. It is an endoparasitoid wasp that measures just 2.5 millimeters long, barely the size of a grain of sand. When this microscopic wasp attacks, the caterpillar's elaborate defenses are useless. The wasp ignores the towering decoy of old heads entirely, and because of its tiny size, it slips effortlessly between the toxic spines. Once positioned on the caterpillar's back, the female wasp uses her ovipositor to inject her eggs directly into the living tissue of the host. Inside, the eggs hatch into larvae. While the caterpillar continues to crawl and feed, the wasp larvae slowly consume it from the inside out, absorbing its nutrients and keeping its vital organs intact just long enough to ensure their own survival. When the wasp larvae are fully developed, they chew their way out of the dying host. They emerge and immediately spin distinct sulfur-yellow cocoons right next to the empty shell of the Skeletoniser. The wasp circumvents the physical armor by weaponizing the caterpillar's own biology against it, turning an impenetrable fortress into an incubator. This diagram illustrates the math. While the caterpillar produces 1 generation per season, the wasp completes 2 distinct life cycles. Breeding twice as fast, the wasp population acts like compound interest. When caterpillars reach peak seeding age, an overwhelming swarm of wasps is already waiting. After rigorous testing to ensure they wouldn't harm native insects, New Zealand researchers released the wasp in 2011. The microscopic infiltrator successfully established itself, aggressively targeting the skeletonizers and drastically reducing their numbers. The Mad Hatterpillar spent thousands of years evolving a highly visible defense against birds, spiders, and larger predators, leaving a blind spot precisely big enough for a tiny wasp to exploit. It shows how strict the rules of ecological warfare really are. A species builds the thickest armor, the sharpest toxic spines, and the tallest decoy. But eventually, an adversary will evolve to slip right past the walls.